In this lesson, we're going to look at the difference between independent, dependent, and mutually exclusive events and how that relates to probability. So we're going to begin by looking at this graphic organizer. So up here at the top, I have that the probability of an event occurring must always be between 0 and 1. Impossible and certain. Most things fall somewhere in between here. So let's talk about the probability of an event not occurring. This is known as the complement. And the notation for a complement, well, if event A is the event, the complement is with a C as like a superscript. And that's equal to 1 minus the probability of event A happening. Think of it like this. If there is a 20% chance that it's going to rain, the chance that it's not going to rain would be rain complement, which would be 80%, subtracted from 100% or from 1 as a decimal. In order for probabilities to be legitimate, the sum of all the outcomes in the sample space must add to 1. Okay, can't have probability greater than 1 or less than 0. So the first two types of events I want to talk about is the difference between independent and dependent. So an independent event is where the outcome of event A is not influenced by the outcome of event B, whereas in dependent, the one outcome affects the other outcome. All right, I'm going to give you some examples to understand this. So to zoom in here, I'm going to jump to the example and then I'll point out the notation. So let's say you're rolling 2 dice. Well, what you get on the first die does not impact what you get on the second die. So let's say I say, what's the probability of getting a 2 and an odd number? Okay, so now let's take a look at how we do this. As long as it's independent, the rule says what we do is we take each probability separately and we multiply them together. This would be equal to probability of a 2 would be 1 out of 6 and means multiply times 3, 6 or 1/2, and that's going to give me 3 out of 36 or 1/12. One other notation, probability of A and B, you're going to see also written like this with an upside down U, probability of A intersected with B. This is known as the intersection, especially if we look at Venn diagrams. Okay, so dependent events, the outcome of one event affects the outcome of another. So that would be like if you are drawing without replacement. For example, if you have a deck of cards and you're drawing a card and I say, what's the probability of a queen of hearts? And you draw a card, you don't put it back, and then a black card. Okay, so queen of hearts, there's 1 out of 52 times half the deck is black, which would be 26, but now you assume you're successful with this queen of hearts, so one card is missing, so now there's a total of 51. So you're just going to multiply that. It's just going to reduce to 1 out of 102. Okay, so mutually exclusive, also known as disjoint events, are two events that can occur at the same time. So if you imagine a Venn diagram, there's no overlap of the two. This is the first time, notice that we use the word or with mutually exclusive, and if they are indeed two disjoint events, we can just add your two probabilities together. The notation that you'll see for this is union. It's like a capital U, a union B. Okay, so you can just add. This would be like you're drawing one card and I say, what's the probability of a queen of hearts or a black card? Okay, so slightly different than before. So again, we said there's one queen of hearts, or means add 26 out of 52 black, because queen of hearts, if you draw that or a black card, you couldn't possibly pull out both. Something that would not be mutually exclusive would be like, what if I said, what's the probability of a queen of clubs? Well, that's a black card, so we have some overlap. So we would be double counting if we just added the two together. Okay, but we'll look at that more in the future. So for now, big picture, independent, dependent both use multiplication, and disjoint or mutually exclusive will use or, and you add Let's do a bunch of examples. We're going to first identify the type of event and then calculate the probability. 2 number cubes are rolled. What's the probability that both numbers are greater than 4? So I'm going to say independent because what I get on the first doesn't affect the second. So probability greater than 4 and probability greater than 4 would be, well, greater than 4 on a die would be that there are 2 numbers. So 2 out of 6 times 2 out of 6 would be 4 out of 36 or 1/9. Okay, I'm just going to express these ones in fraction form. You can change it to decimals. Okay, next, in a bag, there are 4 yellow, 9 blue, and 8 red. Once a pencil is selected, it is replaced, or excuse me, it is not replaced. Well, that's going to make this dependent. Find the probability that 2 blue are chosen. So 2 blue would be blue, and you could also use this symbol of intersection and another blue. So the probability of your first blue would be 9 out of, if I sum how many we have, I believe that's 21. And then I don't put it back. Now the key to this is you assume that you are successful. So rather than there being 9 blue, now there's 8 and there's only 20 pencils in the bag. So I get 6 out of 35. Okay, you draw a card from a standard deck of playing cards. What's the probability that the card will be a black 9 or any heart? Okay, this word or should clue you in that these are disjoint or mutually exclusive. So probability of a black 9, or you could also use the union symbol, any heart. So when I look here, my sample space, a black 9, I see 2 of them. Put the picture there in case you're not familiar with cards. Or any heart, well, there's 13 cards. So if I just add this together, that's going to be 15 out of 52. Now, slightly different scenario in 4. So a card is drawn, the card is not replaced, and a second card is drawn. Okay, so now it has switched to a dependent event. Find the probability of drawing a queen of hearts and a 10. Okay, so probability of queen of hearts, there's 1 out of 52 times, because it's dependent, there are 4 10s right there. But you assume you're successful, so 4 out of 51, which gives me an answer of 1 out of 663. All right, in 5, when spinning the spinner, what's the probability of getting yellow or getting a green or a yellow? So again, that word or tells me disjoint or mutually exclusive. Now when I look at the spinner, I notice that yellow is larger. If I just cut it in half, now it's equal to the others. So if you just look at this, I mean, gosh, it's half, right? But by a proper notation, probability of green or yellow would be 1 out of 6 plus, because they're disjoint, 2 out of 6 or 1/3 would be 3 out of 6, which is a half. Now, if you spin it twice, independent or dependent, this is going to be independent because what you get the first time doesn't affect what you get the second time. And we want to see yellow twice, so this would be yellow and another yellow. So yellow is 2/6 or 1/3. So 1/3 times 1/3 is 1/9.